Hey guys, so here we are, Monday, March 23rd. Uh, should be starting in on chapter 7. Thanks for finishing up the test and the homework. If you aren't done with that, don't stress out. Just get it into me by this week sometime. So do the best you can. Questions, again, give me a call, email, or text, and I'll help you out as much as I can. So 7.1 is exponents. So we're going to be looking at some properties of exponents. Today we're looking at multiplication properties of exponents. So your book should be open to page 391. This is lesson 7.1. Lesson 7.1. So let's just read at the top so we get a little flavor of what we're dealing with here. So a monomial is a number, a variable, or the product of a number and one or more variables with non-negative integer exponents. It has only one term. In the formula to calculate the horsepower of a car, the term W, V over 234 to the third, is a monomial. Okay, is a monomial. Can't have a variable in the denominator. So there you have a variable in the numerator there and one outside the parentheses. An expression that involves division by a variable like AB over C is not a monomial. It's not a monomial. If you look at the AB over C, this is A to the first power, that's B to the first power. A denominator on the bottom is a negative exponent. So in order for it to be a monomial, you have to have a positive exponent. So this would be a negative exponent, and therefore it would not be a monomial. Okay? A constant is a monomial that is a real number. The monomial 3x is an example of a linear expression. Remember when we did our linear, expression, when we had our slope-intercept form, 3x plus 5. This is linear here. Okay, this is linear here. 3x is linear. Excuse me, my computer's gonna die here, so let me just get it plugged in here so I don't lose you guys. Should be working now. Okay, so this is a linear term here. Okay, linear term. It's a monomial. And the exponent of this is 1. Remember, when we have a standalone variable, the variable is going to be 1. Okay? 2x squared is not linear. Okay? If we were to graph this, it would look like this. So it's not linear. This would be graphed like this, where this is a linear equation. This is a monomial that if it was graphed would look like a parabola. It's called a parabola there. All right, so let's take a look at example 1. Example 1, in terms of identifying monomials. A is 10. 10 is just a constant. It's just a number. That would be a monomial. F plus 25. There's two terms there. A monomial is all combined into one term. Okay? This F plus 25 is not, right? F plus 25 or 22 or whatever number that is. This would be a monomial. This would be a monomial, but together they're not a monomial. All right? So those are not a monomial. And then h squared is the third one. H squared is not a monomial. Oh, yes, it is, isn't it? The expression is a product of variables, right? X squared, so it is a monomial. And J on 4 is a monomial. So when we look down to guided practice, okay, we see negative x plus 5. Is that a monomial? No. Two terms. Two terms. So no monomial. How about 1b? What is it? 23abc squared. abcd squared. Right? That's a monomial. When you multiply everything together, that's the product of all of these terms, that would be a monomial. Okay, right? Two terms. Anytime we have an adding or subtracting, that would not be a monomial. Actually, what this is called is a binomial, right? Two terms together would be a binomial. All right? When we look at 1c, 1c would be xyz over 2. That also, what do you think? Is that going to be a monomial? It is, because there's no variable in the denominator. But then when we look at D, example D, when we have MP over N, MP over N, we have a variable in the denominator. Remember what that variable, what the exponent of this variable would be? Who can tell me? Who can -1. Remember, our variables need to have an exponent of 1. When we have a variable in the denominator, again, that's a negative exponent. Now, when we have exponents, if it's repeated multiplication, isn't it? If I have x to the 4th, what's that like saying? It's like saying repeated multiplication. My base is x. My exponent is 4. X times x times x times x. If I have 3 to the 3rd power, repeated multiplication, 3 times 3 times 3. All right? 3 times 3, 9 times 3, that would equal 27. Okay? So we have our exponent and we have our base. Let's turn the page to page 392. Okay, let's turn the page to 392. Now, when we are multiplying exponents, okay, when we have the same base. So for instance, if I have x to the 3rd times x to the 4th, if I'm multiplying x to the 3rd times x to the 4th, as long as I have the same base, x, I can multiply those. This is like saying x times x times x times 4x's. How many do I have altogether? 7. So ultimately what this is like is saying x to the 3 plus 4. So we add them together, right? X to the 3 plus 4, that would come out to the same as x to the 7, okay? X to the 7. And when you look at the top of page 392 in the key concept, take a look at that, and that'll show you an example of what that looks like. Okay, it'll show it to you in variables, and it'll show it to you in numbers. So take a look at that. All right, so we take a look at example 2. I want you to take a look at example 2 yourself and confirm that you know what you're doing with this. We're going to look at the guided practice ones. Okay, we're going to look at the guided practice ones. We have 3y to the 4th times 7y to the 5th. Okay, 7y to the 5th. So here we have variables and we have numbers. So we have constants, we have numbers, and we have variables. When we look at our numbers, we're going to combine the numbers. So we're multiplying the numbers together is all we're doing. 7 times 3, 21. Now, this is saying y to the 4th times y to the 5th. We have 9 total y's. We add the variables together. Would be basically y to the 4 plus 5, which equals 21y to the 9th. So that would be guided practice 2a. Okay, guided practice 2a. And in guided practice 2b, when we look at guided practice 2b, we have in parentheses -4, rx squared t, rx squared t, -6, r5x2t, r5, what was it? x4, r2. Excuse me, t. That's t. Okay, so again, we're going to combine my numbers. -4 times -6. 2 negatives makes a positive. 4 times 6, 24. R times r to the 5th would be r to the 6th. x squared and x squared, x to the fourth. We're going to add those two together. X to the sixth. Okay, x to the sixth. Oh, I wrote that wrong. That should have been x squared here. I'm sorry. X squared, so it'd be x squared. Remember, when we have a standalone variable, what's the exponent with this? 1. What's the exponent with this? 1. And what's actually this one was 3, and the exponent here is going to be 1. So just remember, when you have a standalone variable, it's going to be 1. So we have 24 are 6. 1 plus 5 is 6. My base of x, 2 plus 2 is 4. T3 times and T1, 1 plus 3 is 4 as well. Okay, is 4 as well. All right, so when we're taking the product of exponents, make sure your bases are the same, and then you just simply add the exponents. All right, let's take a look at the top of page 393. Top of page 393, a power of a power. So let's take a look at a real simple example. If we have 4 squared, okay, we have repeated multiplication, right? So let's start out here. We have 2, or a square of this whole thing. So that would make it 4 squared times 4 squared. We add the variables, would be 4 to the 4th. So when we have a power of a power, we can just as easily just multiply the powers together. 2 times 2 is 4. 4 to the 4th. So we look at that on the bottom of page 392. It shows you the concept, that how we just multiply them together. Okay, take a look at that as an example to look at. And let's take a look at the top of page 393. Okay, we have 2 to the 3rd. So let's look what we have. We have 2 to the 3rd in parentheses. Then we have a 2. Then we have a bracket. And we have a 4. Okay? So ultimately what we're doing is multiplying. We always want to start inside, farthest in. 2 times 3 is 6. So we would have 2 to the 6th. And then we would multiply that by 4. 2 to the 24. Okay? 2 to the 24. So when we have a power of a power, this is going to apply to everything inside of here, and there's only one base. There's only one base for it to apply to. Okay? If we had 2x squared squared, this square applies to the 2. 2 squared is 4. We multiply exponents together, would be 4x to the 4th. Okay? So if it's something's outside the parentheses, it applies to everything inside the parentheses. Okay? Power of a power. Okay? So now we have a power of a product. That's what. Take a look at example 4. Okay, take a look at example 4. We have a power of a product, which is basically this. So everything outside, okay, so if we have 3x squared y z to the 4th cubed, we basically have 4 different bases here. My number, x, y, and z. So we apply my exponent to everything inside the parentheses. So basically we have 3 cubed, x squared cubed, and what do we do with the power of a power? 3 times 2 is 6. When we have a standalone variable, what's my exponent with that? A 1. 3 times 1 is 3. Z to the 4th times 3 would be z to the 12th. Then we simplify this to say 27, and then we just continue on and bring the other ones down. Okay? So that's where we have a power of a product. You apply the exponent to everything inside the parentheses. to everything inside the parentheses. And 394, okay, when we look at 394, take a look at those examples. They're getting a little bit more complicated, where remember, apply the exponent to every single base. Okay, so let's look at the key concept of page 394. Simplifying monomial expressions. To simplify a monomial expression, write an equivalent expression in which each variable base appears exactly one, meaning this is x is a base, y is a base, z is a base. And you only want one number as well. Okay? There are no powers of powers, meaning this is a power of a power. So we want to apply the power here to each one of the powers here so that there's no parentheses. We don't want any parentheses when we're done. And the last thing is all fractions are in simplest form, meaning if we have 3, 9, x squared, x, y, 4, y to the 5th. No, we're not going to do that. Okay? Not going to do that. So just remember, we want to make sure all fractions are in its simplest form. All right? So that's our lesson for today. Monday, March 23rd. Check Google Classroom for your assignment. I'm available this afternoon or tomorrow. Please just let me know. Text, email, call me. I will have my book. I will have my Chromebook. If you want to FaceTime, if you want to get on Meets, I will go over things with you. I'll have my whiteboard. I can show you what you need to know. Let me know if you have questions. Take care.